Hi all the students. Today we are going to discuss another kind of guided media, which is your coaxial cable. So what is a coaxial cable? A coaxial cable is also known as a coax in short form. Okay, now coming to the main topic or an important thing, this is the diagram of your coaxial cable. Now this is how the actually the coaxial cable is made up of these layers. So we start with the copper core or the copper conductor, right? This is also known as the inner conductor. So this is the copper core or the copper conductor or the inner conductor, right? So this is from where the actual data flows. The data flows from this copper core or from this inner conductor, whether it is voice data or it is video data, whatever the data is, the data would flow from this particular inner conductor, which is made up of copper, hence it is also known as a copper core or copper conductor. Then there is a layer around this inner conductor or around this copper core, which is made up of an insulating material. Then this insulating material is further layered up or with a braided outer conductor, which is also known as a braided outer mesh. This looks like a mesh kind of a thing, so this is also known as the braided outer conductor or the braided outer mesh. And this mesh or this braided conductor is then further covered with a protective plastic covering. So many layers of covering. The inner conductor, which is actually doing the task of transmitting the data, which is layered up with an insulating material. This insulating material is further layered up with a outer conductor, and this outer conductor is then again layered up with the plastic covering, right? So we'll go into the details of all this. Now let's start with the introduction part. Now the coaxial cable, also known as a coax, is an electrical cable, right? It carries electrical signals, hence it is an electrical cable with a copper conductor, an insulator shielding around it, braided metal mesh, and then a protective plastic covering. So electrical cable with a copper conductor. So this is the copper conductor that we are talking about it. Then an insulator shielding around it. This is the insulator which is shielding around the copper conductor which we are talking about. Then a braided metal mesh. This is the braided metal mesh we are talking about. And then obviously there is a protective plastic covering around the braided metal mesh also, right? So let's start with the innermost layering or the most important thing, that is your inner conductor or the copper conductor, right? So this is the actual conductor, as I told you, which is responsible for the actual transmission of data, be it your voice or your video. Now this copper conductor is the central conductor. Obviously it is the central conductor or the inner conductor which consists of copper. That is why we also call it the copper conductor or the copper core. The reason being that this particular conductor which is transmitting your actual data is made up of copper, right? And it is the very point at which the data is transmitted. So all the layering or shielding that we have is to protect this particular conductor. So it is the main point from which the data is being transmitted. Okay, now the second, the insulator. Now okay, it's quite obvious that the inner conductor is the actual point of transmission. Without it there is nothing, that is the core of your coaxial cable, which is actually responsible for transmitting the data. But then we need to protect that conductor also. That inner conductor or the inner copper conductor needs to be protected. So a protective layering with an insulating material is provided, right? So if I show you the diagram in its simplest form, The previous diagram which I had shown you, or which I just showed to you, was to help you able to distinguish between the different layerings that the coaxial cable consists of. And this diagram will help you to understand in its simplicity that what task each layer is doing. Right, the inner conductor, the insulator, the metallic shield or the braided conductor, the protective plastic covering. So this diagram would help you understand what task each layer is doing, and this diagram helps you understand that okay, these are the layerings to help you distinguish between each pair of layering, that this is one separate layer, this is a separate layer, this is a separate layer, and this is a separate layer. So this diagram helps you understand how many separate layers there are. You can easily distinguish or make out between these separate layers, and this diagram in its simplicity is helping to convey what task each layer is doing. Right, the inner conductor or the copper core, then the dielectric insulator or the insulating material, then the metallic shield or the braided outer conductor, then the plastic covering or the protective plastic covering. So this is a fancy diagram which will help you better understand the different layers, and this is a simple diagram which serves the basic task of making you understand what each layer is doing. Right, now I hope we are done with this diagram. By now you've been able to understand how many layers are there. So from now on we will only refer to this diagram to understand what each layer is doing, why we are having so many layers, and what is the purpose of each layer in this coaxial cable. And to understand that, we will now, from now on, we will refer to this diagram only. Alright, so coming back to the main topic, now we have discussed the copper core or the inner conductor. Now as I told you, inner conductor does the task of transmitting the actual data. Okay, it is very important. Why? Because it is transmitting the actual data, but it is equally important to protect that inner conductor which is transmitting your actual data, right? So that there is no modification of the data. The data is transmitted as it is. There is no interference. So why then comes the role of the insulator. So this insulator or the dielectric insulator that I call it, this is the insulator. So this is the first thing, was your inner conductor. Now the second thing that we are discussing is your insulating material or the dielectric insulator. Alright, now this insulating material is also known as dielectric insulator because dielectric is, why dielectric? Because it is very poor conductor of electric current, right? So since it is a poor conductor of electric current, it is quite obvious that it will provide you with insulation, right? It will provide a shielding or an insulation around the copper core or the inner copper conductor. So hence we use the insulator which is dielectric in nature. Dielectric means it is a poor conductor of electric current, and hence it provides a better insulation around the copper core or the copper conductor. Now this particular insulator that we are talking about, or we are talking of, this particular insulator is used to maintain spacing between the center conductor. Now what is the center conductor? This is the center conductor and the shield. Which shield are we talking of? The braided mesh. This shield I am talking about. So this dielectric insulator or this insulator provides spacing between the inner conductor which is actually transmitting the data and the braided mesh. First of all, it's in itself it is providing insulation, right? And then it further provides spacing between this braided mesh and this inner conductor, right? Okay, now coming on to the braided mesh. Now what is this braided mesh? This braided mesh is again made of copper and it helps to shield from electromagnetic interference, right? Any electromagnetic interference that you have from outside. I'm talking about this particular braided mesh. So any EMI or electromagnetic interference that you have from outside will be protected with the help of this particular braided mesh. It is again made of copper and it is shielding the inner conductor from any EMIs or electromagnetic interference. So why a braided mesh? Because the braid kind of a structure provides a barrier against EMI, right? Or the electromagnetic interference that you call. So when it provides a barrier against the EMI, then it prevents any kind of electromagnetic signals from moving in and out of the coaxial cable. Now when I say moving into and out of the coaxial cable, that means I do not want any data from the coaxial cable to move out, to leak out. Further, I do not want any unwanted noise from the outside to enter inside the coaxial cable, right? So this task of preventing any leakage from the actual copper conductor and any outside noise entering inside the copper conductor, this is prevented with the help of this braided mesh. That is your metallic shield, right? Then you will say that when metallic shield is already providing the task of preventing any EMIs, why are you using this dielectric insulator? Why are you using this dielectric insulator between the metallic shield and the inner conductor? This is because it provides a proper spacing between the inner conductor and the braided mesh and helps to further prevent any unwanted noises, because even if there are any unwanted noises from here itself, they will go away and they will not reach till here, right? So this insulator which I'm talking of, this dielectric insulator, is doing the task of preventing any leakage of signals from the surrounding, right? And the spacing that you are providing, the cable spacing that you are providing, it helps to divert the noise to the ground through the shield itself, right? So this braided mesh is doing the task of preventing any leakage from here and any noise from outside entering here. This is what this metallic shield or braided mesh is doing. And then this particular insulator is providing a spacing between the inner conductor and the braided mesh. And then how does this spacing help? This spacing helps in such a manner that whatever noise is coming here is diverted through this shield itself, and it is not able to reach to this inner conductor because there is a spacing in between. So from here itself it is diverted to the ground. That is why the spacing through the insulator is provided between the metallic shield and the inner conductor. Okay, then at last you have the protective plastic layer. So this is an external polymer layer. It is a layer of a polymer material with plastic coating. So polymer material which has a plastic coating, and it is used to protect internal layers from damages. All right, just like your mother in your house protects your child, but who protects the mother? Mother also needs some kind of protection. To protect the child, mother is needed, and to protect the mother someone else is needed. Mother's mother is needed to protect your mother, right? So all are dependent upon each other. So similarly, the braided mesh is helping to prevent any electromagnetic interference. It is preventing any kind of leakage from the inner conductor. Further, it is also not allowing any outside noise to penetrate into the conductor. But then who is protecting this braided mesh? This protective plaster layering. We are just being sure of being extra protective or providing extra protective layers. So this protective plastic layer, or the plastic jacket that usually people call it, the plastic covering or the plastic jacket, is providing an extra protection to protect the internal layers from damages. Now what are the internal layers? These are the internal layers, because if this braided mesh gets damaged, then it will not be able to prevent any electromagnetic interference from entering inside the inner conductor. So this is doing the task of protecting this inner core, but who will protect this braided mesh? This plastic covering or this plastic jacket. So this is how all the layers are protecting each other, finally to protect the actual data which would be flowing from this inner conductor. Okay, so if I do a comparison between the twisted pair which we have studied in our previous video and a coaxial cable, it is quite obvious and you can easily see that the coaxial cable has a better shielding than the twisted pair. So many layers of shielding, obviously the shielding is better than the twisted pair, and obviously if it has a better shielding, it can span longer distances at higher speeds, right? Now the widely used cables which are used are, one is your 50 ohm cable and your 70 ohm cable. This is I'm talking about the times when we had just begun with the coaxial cables, or after a certain period of time of using the coaxial cables. The earlier versions were like 50 ohm cable or 70 ohm cable. Only these two were available. But the modern cables, or the cables of today's time, have a bandwidth which is closed off up to 1 gigahertz, right? So the maximum the bandwidth that can go is up to 1 gigahertz. Earlier it was restricted to two kinds of cables. One was your 50 ohm cable and another was your 70 ohm cable. Then later on, in today's time, I can say that it can have a bandwidth or close of up to 1 gigahertz. Right? And further, the bandwidth also depends upon certain other factors like what is the cable quality, what is the cable length, and what is the signal to noise ratio. So this is your coaxial cables. Now, what are the applications of coaxial cables? Where all can you use your coaxial cables? There are various applications wherein you can use your coaxial cables. You can use them in your televisions. Internet cable for transmitting data uses your coaxial cable. Your CCTV cameras that you have installed inside your homes have your coaxial cables. For videos, you can use coaxial cables. Further, obviously for the high definition television, coaxial cables are used. Now, what are the advantages of coaxial cable? Of course, it is a high bandwidth. It is easier to install. It is more reliable because better shielding means better reliability, and it is less affected by noise or crosstalk. So many shieldings obviously preventing any kind of electromagnetic interference. So lesser noise and is less affected by the crosstalk. Crosstalk is what you hear. What you don't want. Crosstalk is like data from someone else's side. Like in earlier times when you had landline phones, you were having a conversation with someone else, and at the same time you could hear some other people also communicating. So that was a crosstalk. So it prevents any crosstalk. Now, what are the disadvantages of a coaxial cable? It is quite expensive, and it must be grounded to prevent crosstalk. So if you want to prevent any crosstalk, the coaxial cable must be grounded. Since it has so many shieldings, obviously it is bulky and then it is easier to hack. So these are the disadvantages of a coaxial cable. So this is all about coaxial cables in today's lecture.